Hello everyone, welcome to the Tinkercad tutorial for APSC 200. First of all, what is Tinkercad? Well, Tinkercad is a lightweight web-based CAD software designed by the makers of Autodesk, and it allows you to create 3D designs and also circuits, including Arduino simulations, on a web-based free platform. So today I'll be going over the basics of how to create circuits, manipulate components, and then share your designs with others. So this here is the main dashboard that you will see when you first sign into Tinkercad. And if you don't already have an account, you can go to tinkercad.com, click join now at the top right, and create a personal account, and then you can choose one of the sign up options here. So once you sign in, you will be brought to this page, and then you can navigate to the circuits tab and create a new circuit. So now that it's loaded here on the right, you can see we have the components available, and we will just click this drop down and switch to all components to see everything that is available for use. So now the first thing we want to add is a breadboard. So down in the breadboard section, we can add one of these small breadboards here. And then if we go a little further into the microcontroller section, we can also add an Arduino Uno. Now that we have some components in here, if we click and drag anywhere, we can move around, and scrolling the scroll wheel will zoom in and out. So in this tutorial, we'll be making a simple circuit with a push button and an LED. So we'll drop in an LED here, and then up at the top, we can grab a push button as well as two resistors. We'll need one for each component. And so we can remember that on a breadboard, the rows here are connected and then broken in the middle, and then the ones over here are connected as well. And this is seen by the green markings. It reminds you of that. And then similarly, these bus connections on the side for power and ground are connected all the way along. So we can pop in our LED, let's say right here, and our push button we can put just in the middle here. And so now we need to add a resistor in series with the LED. And so in order to do that, we probably want to rotate our resistor sideways. So up in the top left, there's this rotate button that we can click and rotate the component and then line it up so that it's connected to the anode of the LED. And then we can do a similar thing with the other resistor for the push button. We can rotate that one 90 degrees and connect it here. And so now we will need some wires. So let's first connect up the power and ground from the Arduino, so the 5-volt and the ground pins, to the ground and power rails of the breadboard. We can do that by clicking once on the ground here, and then clicking again where we want it to be connected. And then the same for the 5 volts. Now we can see this is a bit hard to see what's going on and where everything's connected, but if we double click on one of the wires, it adds a little bend point here that we can move. And let's add one more. And this helps us follow, keep it nice and clean and see where all the connections are going. And let's actually do one more thing. We'll move this over one spot just so there's no overlap of the wires. And finally, we can change the color of the wires to keep the color coding consistent. We can set the black or the ground wire to black. So just from up here on the color option, and if we select the 5-volt wire, we can make that one red. And that's just a standard convention, so it's easy to see what wires are doing what. And so now we will add some connections to the Arduino's digital pins, so we can turn on the LED and we can read what state the button's in. So first we're going to connect digital pin 3 to this side of the resistor, which then goes to the anode of the LED. And again, we'll bend this one up like this, double clicking to add these bend points. And also we will add digital pin 2 to the one side of the button here, and clean this up as well. And now since these are digital signals, not 5-volt power, we probably want to change the color. So I'll set this wire here to green, and let's say this one here to yellow. Now for these digital signals, you can pretty much choose whatever color you want, but I like to use green for an output. So in this case, we're using D3 to set an output to the LED, and we're using digital pin 2 to take an input from the button. So if you had more components, you could make all your inputs yellow and all your outputs green, just so it's easy to read, but totally up to you how you do that. And then finally, we'll have to make a couple more connections from the cathode of the LED. We'll connect that down to the ground rail here, and then we'll make that wire black. We'll also connect the other side of this resistor here to ground. And finally, we'll make a connection from the right-hand side of the push button down to the 5-volt rail and make that one red. And so now, when the button is pushed, it'll connect the 5 volts from this side of the button over to this side, and the Arduino will see that 5 volts on this rail of the breadboard here. And if the button's not pressed, it'll be connected to ground through this resistor, and the Arduino will see 0 volts on this rail and know that the button is not being pressed. So now that our circuit's wired up, we want to put some code on the Arduino and see if it works. So up on the top right here, we can open the code tab. And now when you first open it, it'll open this block view. It's useful if you want to try an experiment with different algorithms or whatnot, but it doesn't translate well to a real Arduino. So we'll click the drop-down menu and switch to the text mode, and we can click continue there. And so I have some code I already wrote for this circuit that I will just paste in, and of course this will be available on OnCue if you'd like to try this out yourself. And so now that the code is in here, we can just click start simulation and ignore this debugger message, and you'll see that the USB cable is now, well, the simulated USB cable is connected to the Arduino, and the Arduino is powered on with the power LED there. So now if we click on this push button here, we will see that the LED lights up, and when we're not clicking it, the LED is off. And we'll also notice here, if you take a look at the code, that when the button state is high or the button is being pushed, we should also be printing something to the serial monitor. And so if we want to look at what's on the serial monitor, we can open the serial monitor by clicking on it down here, and you'll see when I push on this button, it writes to the serial monitor that the light is on. And then it's a bit hard to tell now that it's full, but when you stop pushing the button, it does stop, and we can see that if we clear it here. Okay, so now that we have our first circuit complete, let's talk about how you could share this with a group mate or a partner. So first of all, let's stop the simulation, and that allows you to continue to make changes. If the simulation is running, you can't make any changes. So now that that's stopped, we can go back to the Tinkercad dashboard by clicking on the Tinkercad logo up here, and we will see all our circuits here. And now, so this is the one we were just working on. If we click on the settings and go to properties, we have the option down here to, well, first of all, change the name, and secondly, make this to public so that it's viewable and discoverable by everyone. And we can save the changes. And now if we click on it here, we'll see there's a link here, and if you send this to someone, they will be able to open it, make a copy of your circuit, and then build on it, change the code and whatnot. And so if we want to go back into the editor, we can just click on Tinker this, and that takes us back into the circuit. So those are the basic features of how to use Tinkercad, and you'll see there's a lot more components that we didn't even touch, so lots of options. You can play around with this, try it out for your project, and if you want to try out this exact circuit, there will be pictures and the code will be provided on OnCue.